In this video, we're going to talk about how you can assign a number of significant figures to each kind of number that you'll come across in chemistry. Our first types of numbers will have these things called leading zeros on them. These are numbers that you would usually think of as tiny, like 0.1 or 0.10 or 0.101. In each case, these numbers have different numbers of significant figures. We never count the first digit of a leading zero, so you don't count this 0. The decimal place is a really good indication of when we need to start paying attention to our number as a whole. In our first case, we have one digit after our decimal point, and that digit is a non-zero digit. So we would count that as one sig fig, or a significant figure. The next number has a non-zero digit and a 0. So we would call that 2 sig figs. And we need to report both of those numbers. In our third example, we have a 1, another 0. This one kind of counts as a regular number, and we'll talk about that in a second. And another 1. All three of those digits are important. So we'd say that is 3 sig figs. These examples are pretty simple, but what if you had a 0.001? How many sig figs is that? Is it 3? Is it 1? Is it 4? What's going on? Well, in this case, we actually have 3 leading zeros. These are considered placeholders. You could even write that number as 1 times 10 to the negative 3, and it would have the same exact meaning. So we would say that this number only has one significant figure. Our next type of number has something called a trailing zero in it. Examples of things with trailing zeros. We have 0.0010, 200, 2.00, 200 with a decimal place at the end, and 200 with an extra decimal at the end. In this case, sometimes we count trailing zeros. In this case, the 0 is happening after a digit and decimal place, so we definitely count that one. This number has 2 significant figures. In our next example, there is no decimal place, so this could be a number that's an estimation, like, oh, that's somewhere between 100 and 300. We have no idea. This is not a very accurate number. So we would not count these trailing zeros. This has one significant figure. And it would honestly be better reported as 2 times 10 to the 2. The next number is clearly measured on a better device than our previous one. It has 2 decimal places after the decimal. We would include all 3 of these numbers in our sig fig count. So that 2.00 has 3 sig figs. This 200 is actually much better measured than our first 200. It has a decimal point at the end, so that indicates that our measuring device is accurate up to this last uncertain digit. So we would call this one 3 sig figs. Our last digits here in this 200.0, this is an even better measuring device than the last 200 because we have the uncertain place in this last set of numbers. So we would call this one 4 sig figs. Our last types of numbers are called trapped zeros. Trapped zeros always count for significant figures. Here are a few examples. 1.001 from before. This guy has 4 sig figs. In this case, it wouldn't matter whether those zeros were zeros or numbers because our last important digit is after them, so we definitely count them. Another example is 202. This one has 3 sig figs. We treat that 0 as if it's a digit. And the last one from scientific notation land, 1.03 times 10 to the 3. This number also has 3 sig figs. It's important to note in scientific notation that we only use these first 3 numbers to determine the significant figures. The times 10 to the stuff, that doesn't count. Those are placeholder zeros. And now you know all you need to know about assigning the number of sig figs in a number.